In this lesson and the next one, we're going to look at solving those right triangles with altitudes a different way. And this one involves something called the mean proportional. So first of all, we're going to review the parts of a right triangle, which should be old news to us. We have the hypotenuse. So once you find the right angle, the hypotenuse is going to be the side opposite that right angle. So here's our hypotenuse. He's there, and on this one, he's going to be right there. The other two sides are called the legs. So that's really it. We have the leg, and over here the same thing. The two sides that make up the right angle, those are the legs. And that's what we're going to refer to, either the hypotenuse or the leg in the problems that we do. Now we have something called the mean proportional. We're not really reviewing it because we haven't talked about it before, but the mean proportional is what you get when you take two numbers and you set up the variable as the lower left, upper right. So those are the product of the means, and the other two are the product of the extremes. So let me just kind of show you in an example here. If I'm going to find the mean proportional between 4 and 9, here's what I do. That doesn't mean the average of 4 and 9 or the middle number. What you do is this. You set up your variable so they are diagonal from each other, usually lower left, upper right, and then the other two numbers go in there. And you cross multiply. So when you cross multiply, you get x squared is equal to 36. So in this case, the mean proportional is going to be positive or negative 6. When you take the square root, you can either have a positive or a negative 6. Now when we deal with triangles and we talk about the mean proportional, when we're dealing with distances, we're just going to take the positive value. You don't have to have a perfect square when you're done. We'll do one more, so we're not going to do this one. But the mean proportional between 3 and, let's say, 18. Again, what you do, the mean proportional is going to be the x value. We put him in the lower left, upper right, and then the other two numbers go in place, and then you cross multiply. X squared, and that's an 18, not an 8. X squared is equal to 54. So the mean proportional is going to be plus or minus radical 54. Okay, so we're going to use this mean proportional in our definition of a right triangle with an altitude. But we have to define a couple other things before we get started with the examples. So we also have to define what a projection is, the projection in these problems, because that's a term I'm going to use. So the projection of a segment is basically the shadow it creates underneath the segment. So the projection is the shadow a segment makes. From the vertical direction, or from usually the vertical direction. So let me kind of demonstrate what this means. The projection, if I look at the first segment here, its projection would be, if I were to shine a light up here, it would be the shadow that that thing makes. So the projection in the first case would look identical to the original. In the second case, if I'm thinking about the projection, it's going to be a segment that looks shorter. So it's the segment that results when you just kind of, if you were shining a light, it would be the shadow that created from the vertical line. So the third one, if you think about it, again, its projection would just be a single point because everything is lined up vertically. So now if we look at triangles and we think of projections, if I look at this side, its projection is going to be this segment here. If I look at the other side, so I'll use the second triangle to look at the other side, its projection is going to be the horizontal line that represents the other half. Now if you look, those two projections, if you were to combine them, they would make up the entire segment at the bottom here. So that's what projection is. And now we have a theorem that's different than, or it's kind of built on what we did yesterday with the similar triangles. Only what we're going to learn today and tomorrow kind of gets us away from having to draw those triangles all the time. So here it is. If the altitude is drawn to the hypotenuse of a right triangle, three things occur. And then again, this is what we talked about yesterday. The two triangles formed are going to be similar to each other. So this is what we can say. The two triangles formed are right triangles and are similar to each other. Again, if I take this and I drop the altitude at the right angle, there's our three triangles. We have, if I label this D, again we have triangle ABC. This is what we did yesterday. And we have triangle, if ABC is one of them, that means I'm traversing the hypotenuse from the short end. So the next one would be ACD, and then triangle CBD. Those three are all similar. So here's where we get into a different definition. Because of our setup yesterday, we can say that the altitude is the mean proportional between the two hypotenuse segments. So we just defined what a mean proportional is. The altitude is going to be the mean proportional between the hypotenuse segments, which means this. CD is the mean proportional between AD and DB. How you would set that up to solve? Remember, the mean proportional means whatever that measurement is, whether it's the variable or whether you have a value for it, that little altitude is going to go lower left, upper right. And then the other two segments, AD and DB. If you look at what we did yesterday in the notes and in the practice in class, you will see that when we had an altitude, its value would be lower left, upper right every time when you set this up, and the other two sides are the other two. We call these two the means and these two are the extremes, and that's how you would set it up. So that's if you're involving the altitude. The other part of this is if you're not involving the altitude but a leg. Each leg of the right triangle is the mean proportional between the hypotenuse and the leg's projection. So each leg of the right triangle is the mean proportional between the hypotenuse and the leg projection. So when I talk about hypotenuse, I am only talking about the hypotenuse of the largest outside triangle. Okay, this is really the only triangle we're dealing with today. So I want you to think in terms of one triangle with an altitude. So each leg, this leg here, is the mean proportional between AB and AD, because AD is the projection of AC. If I look at the other leg, CB is the mean proportional between AB and DB, because DB is the projection of CB. So I'm going to set those two up. Each leg is the mean proportional. So if I have leg AC, I'm going to put AC in where the mean proportional goes. The hypotenuse is AB, and its projection is AD. We can do the same thing on the other side. And now we can say CB is the leg I'm talking about. CB is going to be the mean proportional between the hypotenuse AB, so the hypotenuse doesn't change, and the leg projection DB. Okay, so this is hypotenuse leg, leg projection. Hypotenuse leg, leg projection. Okay, and that seems to be the best way to do this. This memorizing stuff at the bottom we're not going to deal with. Because these two things seem to be sufficient when we start working through these problems. So we're going to write these setups again. The first one was the altitude. So the altitude is the mean proportional between the two hypotenuse segments. So I'm going to simplify that, hypotenuse segment and hypotenuse segment. That's the first one. So the altitude is the mean proportional between those two segments that make up the hypotenuse. The second one is the entire hypotenuse over the leg, so the leg is the mean proportional between the hypotenuse and the leg projection. Okay, those two things, if you can figure out those two things, you can do any of these problems. Again, we're going to solve these problems. If there's a radical, we're not going to simplify them all the way because we're going to get into that later on in the unit. By the end of the unit, you're going to be expected to reduce these things to simplest radical terms, but not today because that's we're a little bit out of order with what I wanted to do. Okay, so the first one we're going to have CD is 2, DB is going to be 8, and we want to find AD. So I want to put my x value here. I know CD is 2 and DB is 8. When the altitude is involved, that means we're going to use hypotenuse we're going to use the altitude as the mean proportional between the two hypotenuse segments. So here's what we do. We put down our altitude first, and we make that the mean proportional. I'm trying to find one segment, and here's the value of the other segment. So it's on the setup. Once you get that, you cross multiply and you solve. By cross multiplying, I get 8x is equal to 4. And so in this case, x is going to be 4 over 8, which is 0.5. Now drawings are not going to be to scale here because you can see we're using the same diagram in each case, so you just have to go by the numbers and not by what the diagram looks like. For the next one, we're going to say that AD is 5 and CD is going to be 10, and we want to find DB again. So once again, we are looking for, this is the situation where the altitude is involved. We have AD is 5, CD is 10, and we're looking for this guy. We put down the fact that the altitude is the mean proportion, so the 10 goes in lower left, upper right. That's the one we write twice. And then the 5 goes in one spot and the x goes in the other. Cross multiplying, 5x is equal to 100, and in this case we have x is 20. Okay. Alright, the next one is going to use the other setup, because if you look at it, we're going to have AD is 10 and AB is going to be 25. So in this case we want to find AC. So this is different. The altitude is not involved. So we know that the leg is going to be the mean proportional between the hypotenuse and the projection. So if I look at this, let's set this up. We have the leg is going to be AC, so that's going to be x. And AD is going to be 10, and AB is going to be 25. So the leg is the mean proportional. We have an x and an x, and then I have a 10 and I have a 25. So in this case I have x squared is equal to 250. Now 250 is not a perfect square. If you take the square root, let's say we round to the nearest whatever, you're going to get about 15.8. So if we want to do that, we can say x is approximately 15.8. Again, later on in the unit we'll reduce radicals to lowest terms and keep them exact. Alright, we'll do a couple more examples here. The next one, we're going to have AC is equal to 4, and AD is going to be 2, and we want to find AB, the hypotenuse. So again, we have a 4, and we have 2, and now we're trying to find the hypotenuse. This is the same setup though. The leg is going to be the mean proportional between the hypotenuse and the projection. So if I put the leg in there, that's a 4. I put them in lower left, upper right. I'm trying to find the hypotenuse, and then my other number is 2. Cross multiplying, 2x is equal to 16. So in this case we have x is 8, AB is 8. One more example. Let's say AD is 3 and DB is 8, and we want to find, let's make this slightly trickier. Let's say we want to find AC. How would we do that? We have AD is 3 and DB is 8, and I want to find this guy. Well, you have enough information to do it, because remember, the leg is going to be the mean proportional between the entire hypotenuse and the projection. I have the projection. To get the entire hypotenuse, I just got to add these together. So that's going to be 11. So we're going to get some kind of radical, but that's okay. So to do this, the mean proportional is the leg, so I have an x and an x, and then 11 is the hypotenuse, and I have 3, which is the projection. So cross multiplying, you can say x squared is equal to 33, so x is going to be radical 33, or we could put that in our calculator and round for the approximate value. Let's say we want to find CD now. Using that, do I have enough information? If I want to find CD, I'll call him Y. I should be able to, because The altitude is the mean proportional between the hypotenuse leg segments. So this is where I'm going to use the separate values. And let's find CD. This time my variable, well, same as before, it's going to be the mean proportional. That's not always the case. And then here's my other two numbers. So when I cross multiply, I get y squared is 24. So y is going to be radical 24. That's 2 radical 6, or we can round to the nearest decimal. So this is a brief introduction of how to solve these right triangle problems without breaking down similar triangles. And if you can understand mean proportional, you can do these pretty quickly.